In section 9.5, we are going to be looking at the product and quotient rules. These will allow us to find derivatives for functions that have multiplication and division in them. We are going to start with the product rule. If you have a function f of x that is made up of two functions that have been multiplied together, u of x and v of x, then the derivative of f prime, will be u of x times v prime, the derivative of v, plus v of x times u prime, the derivative of u. So a little saying that you can chant to yourself while you're doing this is first times the derivative of the second plus second times the derivative of the first. Even after all these years of doing calculus, I still say this to myself when I'm doing the product rule. For our first example, we are going to start with the function f of x equals x cubed times the quantity x squared minus 5. The first thing you want to do is figure out where the multiplication is happening, because that determines which of your functions is the first and which is the second. Our multiplication in this example is happening between the x to the third and the parentheses that surround the x squared minus 5. So x to the third is the first and the x squared minus 5 is the second. So now that we have that figured out, we can begin finding this derivative. So when the derivative formula says u of x, it means write down the first function exactly as it was given to you. Our first function was x cubed. Take that times the derivative of the second. Our second function is x squared minus 5. The derivative of that will be 2x. And then it is always plus in between. And then when it says v of x, that means write down the second function exactly as it was given to you, x squared minus 5 times the derivative of the first. The derivative of x cubed is 3x squared. So at this point, you are done with calculus. You need to multiply and combine like terms in order to simplify your answer. X cubed times 2x gives you 2x to the fourth. On this second term, we're going to need to distribute. So 3x squared times x squared will give us 3x to the fourth. Negative 5 times 3x squared gives us minus 15x squared. Notice that we have like terms, so combining those like terms, we will get 5x to the fourth minus 15x squared. And this now finally is our simplest form of the derivative of our function. On our second example for product rule, we have the function f of x being the quantity of 3x plus 5 times the quantity of x minus 8. So the multiplication is happening between the two sets of parentheses. So when we are ready to find our derivative, then write down the first part exactly as it was given, 3x plus 5, times the derivative of the second. The derivative of x, remember, is 1. Always plus, then write the second as it was given, times the derivative of the first. The derivative of 3x plus 5 is going to just be 3. So cleaning this up, 3x plus 5 times 1 is 3x plus 5. Distribute your 3, you're going to get plus 3x and minus 24. Combine the like terms, you get 6x minus 19. And that is your final answer for the derivative. The quotient rule says if f of x is some function u of x divided by a function v of x, then f prime, the derivative, will be v of x, exactly as given, times u prime minus u of x, as given, times v prime over v of x, which was your original denominator, squared. So a little saying to help you get this as you're doing it: low d high, where d stands for derivative, minus high d low over low squared. For our first example, doing the quotient rule, our function is 2x plus 3 divided by x minus 7. Following our rule, then, to find the derivative, you start with the denominator, the low, as it was given, x minus 7. Take that times the derivative of the high. The derivative of the numerator will be just 2. Always minus. Now write the numerator exactly as given, that's the high, times the derivative of the denominator is going to just be 1. All that goes over the entire denominator, which in this case is x minus 7, squared. Do your distributive property in the numerator. You will get 2x minus 14. Now 1 times 2x minus 3 is just 2x minus 3, but I need to distribute the negative, so it would become minus 2x minus 3, all this over the denominator squared. You can do the FOIL on the denominator, but you do not have to. It is absolutely fine to just leave it as the quantity squared. Notice that in our numerator, we have a positive 2x and a negative 2x that will wipe each other out. This is fairly common. It doesn't happen all the time, but it does happen frequently. When you look at what's left, we have negative 14 and negative 3, which gives us negative 17 over the quantity of x minus 7 squared. And that will be your derivative of f. On example B, our function that we are given is x squared minus 3x over 2x squared plus 5x. Putting our quotient rule into practice, we start with the denominator exactly as it's given to us, 2x squared plus 5x. Take that times the derivative of the numerator, which will be 2x minus 3. Then it's always minus. Now start with the numerator, x squared minus 3x, times the derivative of the denominator will be 4x plus 5. All of that goes over the entire denominator, 2x squared plus 5x, that is being squared. When you look at this numerator, notice that we need to do FOIL on both of these sets of parentheses. We are going to get 4x to the third minus 6x squared plus 10x squared minus 15x. On the second part, we not only have to do FOIL, we also have to distribute a negative sign. This will give us negative 4x to the third minus 5x squared plus 12x squared plus 15x. And all of this is over our denominator being squared. To clean this up, we are going to combine like terms. We have a positive 4x cubed and a negative 4x cubed. We have a negative 15x and a positive 15x. So those things have all offset each other and given us zeros. Now, if we combine all these squared terms that we have, the first two will give us a positive 4x squared. Minus 5 gives me negative 1x squared. Plus 12 gives me 11x squared over 2x squared plus 5x, the quantity squared. Our first application example says during the course of an illness, a patient's temperature in degrees Fahrenheit, X hours after the start of the illness, is given by T of X equals 10x over x squared plus 5 plus 98.6. Find the formula for rate of change of the patient's temperature. Then find the change in temperature at 0, 1, and 3 hours and interpret the answer. We know that we need to find the derivative for this reason. Formula for rate of change. Anytime you're talking about rate of change, you are doing the derivative. The derivative of t, then, notice that your function is fractional in form, so we need to do the quotient rule. Start with the low as given times derivative of the high. The numerator will just be 10. Always minus, then the high as given, 10x, times the derivative of the low. Derivative of the x squared plus 5 will be 2x. All that goes over the entire denominator, x squared plus 5, being squared. So this is the derivative of this part. But notice we have another term here. We have plus 98.6. Well, that's just a constant. What's the derivative of a constant? It is 0. Let's clean this up. If we take 10 times x squared plus 5, we will get 10x squared plus 50. Multiply after the minus, you will get 20x squared over x squared plus 5, quantity squared, and then we don't need to write the plus 0. Cleaning it up, because we have like terms, we're going to get negative 10x squared plus 50 over our denominator quantity squared. So there is our formula for change in temperature. Then the problem goes on to say, now find and interpret change in temperature at 0, 1, and 3 hours. So what's happening at 0? If we put 0 into this thing, we will have 0 plus 50 over 0 plus 5 squared. So we will get 50 over 5 squared is 25, which is 2. Because our answer is positive, we know that the temperature is increasing 2 degrees from our 0 to our 1. Then we are asked to do t prime at 1. If we put 1 into our function, we will have negative 10 times 1 squared plus 50 over 1 squared plus 5 quantity squared. So we will get negative 10 plus 50, which is 40 in the numerator. 1 plus 5 is 6, squared is 36 in the denominator. And this gives you about 1.1 degrees. So what does that mean? The temperature is, because it's positive, increasing. How much? 1.1 degrees from the hour that you put in 1 to the next hour, hour 2. Then finally, we are asked to do t prime at 3. If we will do that, we will have negative 10 times 3 squared plus 50 over 3 squared plus 5 being squared. So 3 squared is 9 times negative 10 gives us negative 90 plus 50 gives us negative 40 over 9 plus 5 is 14 squared is 196. Work that, you are going to get about negative 0.2. So what we know now is the temperature is decreasing because it's negative. How much? 0.2 degrees from hour 3 to hour 4. On example 4, we are asked to find the equation of the tangent line to the graph of the function at the given point. We need to find a derivative because we are asked for equation of a tangent line. Anytime you're talking about a tangent line, you need the derivative. First thing we're going to do is find the derivative of f. What you need to notice is that this is first and second being multiplied here, so we're going to do the product rule. So we're going to do the first exactly as given, x cubed plus 1, times the derivative of the second, which will be 6x minus 4, always plus, second exactly as given, 3x squared minus 4x plus 2, times derivative of the first, 3x squared. You will need to do FOIL on the first two. Doing FOIL there gives us 6x to the fourth minus 4x cubed plus 6x minus 4. Then we need to distribute the 3x squared, so that will give us plus 9x to the fourth minus 12x cubed plus 6x squared. Now if we put all of our like terms together, we will have 15x to the fourth. So we did our fourth terms. Now let's look at our cubes. We're going to have minus 16x cubed. So there's our cube terms. Now everything else are just single terms. So we're going to have plus 6x squared plus 6x minus 4. This now is the formula, it's our derivative, and it is the formula for slope of the tangent, because in this case we were talking about a tangent line. If we want to write the equation of the tangent line, we need a point, which we were given. Here's our point. What we need now is the slope of the tangent line. So the slope of our tangent at x equals 1, if we put 1 into this, we will get 15 minus 16 plus 6 plus 6 minus 4. So we will get negative 1 plus 12 minus 4, which gives us 7. Now do point slope formula. Y stays as the variable, minus the y of your point is 2, equals our slope was 7, x is the variable, minus the x of the point is 1. Y minus 2 equals 7x minus 7. Add your 2, you get y equals 7x minus 5. And that is your equation of the tangent line. On example 5, it says, let the function f of x be the quantity x squared plus 1 times the quantity 2 minus x. Find the point or points on the graph of f where the tangent line is horizontal. As soon as you see talking about tangent line, it tells you that you need to find the derivative. And if we look at this function, it is two quantities being multiplied, so we are going to need to do the product rule. X squared plus 1 will be our first, and 2 minus x will be our second. Doing our product rule, we take the first as it's given, so we will have x squared plus 1 times the derivative of the second. The derivative of 2 is 0. The derivative of negative x will be negative 1, always plus between. The second as given times derivative of the first will be 2x. Distribute your negative 1, you will have negative x squared minus 1. Distribute your 2x, you will have plus 4x minus 2x squared. Combine your like terms, you will have negative 3x squared plus 4x minus 1. So now this is our derivative, and we have been asked to find where the tangent lines would be horizontal. We've done this before. Remember, we talked about if it's horizontal, that means that the slope equals 0. And we know that the derivative is the formula for slope of a tangent. So anytime your problem talks about finding where the tangent is horizontal, you're going to take your derivative and set it equal to 0. How do we solve a problem like this? Well, we're going to try to factor it, but the first thing is that it's a negative 3x squared. So I'm going to factor out the negative, or negative 1. That will give me 3x squared minus 4x plus 1. Now, keep this negative 1. We're going to factor the 3x squared minus 4x plus 1. If my first term is 3x squared, then I must have a 3x and a 1x. If my middle sign only is negative, then both factors have to be negative, and the only thing that multiplies to equal 1 is 1 and 1. Do a quick check for yourself. Here's 3x squared minus 3x minus 1x gives me minus 4x, and then negative 1 and negative 1 gives me plus 1. So let's get these out of here now. So we know that we did factor correctly. And then when we are solving this, this means we need to set each of these factors equal to 0. If you have pulled out a constant like you did here, you can ignore this because you can't set negative 1 equal to 0. That doesn't make any sense. You can only set the item that you factored out equal to 0 if there is a variable. We are only going to use the 3x minus 1 equals 0 and x minus 1 equals 0. Solving on this first little equation, we're going to get 3x equals 1. Divide by 3, you get x equals 1/3. Add 1 on the other equation, you get x equals 1. These are the two x values where you would have a horizontal tangent line. That means in the graph, they would either be a peak or a valley, or mathematically, they would be turns. If you look at the question, it doesn't just say find the x values where the tangent is horizontal. It says find the points where the tangent is horizontal. Anytime you want to find the point, that means that you have to take your x value and put it back into the original to find the y value. So for our problem on the first one, y will equal 1/3 squared plus 1 times 2 minus 1/3. And if you do this calculation, you will get 50 over 27. So the first point is 1/3 50 over 27. For the second point, you'd have y equals 1 squared plus 1 times 2 minus 1. Do that arithmetic and you will get 2. So our second point happens at 1, 2. So these are the actual points for the turns of this graph.